All right. So we have this town, population is growing. We're going to see if we can make a prediction about it. So first we have to formulate what's happening here. So we know they're starting at 72,000 in 2010. So a table might help. So I think I might choose X to be years after 2010 to make things easier. And then we have the people. So we know that 0 is 2010. The population is 72,000. And then we want to look into the future and figure out when the population is going to be 160,000. We know it's growing by 8%. So when we have growth or decay equations like depreciation or interest or people, the formula generally looks something like this. Y equals some starting amount times some base amount, and let's say to the power x, and that's usually time. And the base usually comes from 1 plus some rate, and that rate could be positive or negative. In this case, we have a rate of 8%. So the 1 is 100%, so that means our growth multiplier is 108%. C is our starting point. So for this situation, the town's population, the people, Y, is going to be 72,000 times the base is going to be 1 plus 8%, so 108% raised to the power x. I really don't need parentheses here, but with the 1 plus, we usually write it. And that's it. Well, if I knew the year, I would just plug it in, I would get an answer. So I could guess, like, hey, what's happening 10 years later? Then y would be equal to 72,000 times 1.08 to the power 10. I could ask my calculator what it thinks about that. So 72,123 times 1.08 raised to the 10th. And I get, ooh, I typed something wrong there. Try again. Helps if you push the right buttons. Seem to have missed the power button. I think I got it that time. Okay, that looks better. 155,000. Ooh, that was a pretty close guess. 10 years. I had no idea. All right, so I could keep guessing 11 years, 12 years, and so on, but this problem wants a fraction of a year, so that's going to be a waste of my time. So I'm going to try and solve this. So back to our, oh, there you go. We want to know when is this equation, or this equation right here, when is that going to be equal to 160,000? And instead of knowing it's 10, we don't. That's just an x right there. So I need to solve this right here. Let's bring that into a new page. So I've got my 72,000 times that 1.08, just rewriting it on a clean sheet. And let's see, I'm using x instead of t, equals 160, 1, 2, 3 zeros. So to solve something like this, we need to get the x alone, so we need to get the base alone, so we're going to get rid of that multiplication by dividing by 72,000 and cleaning it up a little bit. So on the left side, we have a number divided by itself, which is 1, and 1 times 1.08 to the x is 1.08 to the x. On the other side, we can clean this up a wee bit, and we can divide top and bottom by 1,000. That's 160 over 72. Let's see, we could cut each of those in half. Right, divide by 2. Maybe you have a calculator that does this for you, so that'd be 80 over 36. Cut it in half again, 40 over, would that be 18? Wow, it keeps going. 20 over 9, hopefully that's correct. Let's double check on a calculator. And again, we could use the decimal version, but that can get kind of messy and introduces rounding error. But if you hold a lot of decimal places, it's no big whoop. So let's see, I think it's 20 over 9. What does my calculator think? That was what, 72 No, let's see, no, it's clear. 160 over 72. I was pretty confident about getting rid of those thousands. But it couldn't hurt to check that too. So 2.22222, a whole lot of twos. I thought it was 20 divided by 9 when I reduced it. And I did pretty good math today. Nice. All right, so I'm going to go with that simple form. Otherwise, you could just leave it as 160,000 over 72,000. It's going to work out the same way. Or you could hold on a whole bunch of those decimals. You'll get pretty close to the right answer. I'm going to go with my reduced 20 over 9. To get rid of the power, next I apply logarithms. So I'm going to take the log of both sides and put parentheses there to be safe. And inside over here I have 1.08 to the x, and over here I have 20 over 9. The trick on the left is that the log of a base to a power, that power pops out times the log of the base. And I'm capitalizing the word log. It doesn't matter. Lowercase log, uppercase log, it's still log base 10. So the notation I'm using, log base 10 of something is the same as log lowercase of something, which is exactly the same as capital LOG on most computers. Every once in a while there's a different meaning for that, but let's ignore that for now. On the other side, I'm still stuck with the log of 20 over 9. Now, the thing here is that this is just some number, and it's being multiplied by x, so to get rid of it, I'm going to divide by it. So dividing by log of 1.08 on both sides. I'm ready to use my calculator, because a number divided by itself on that side is 1. 1 times x is x, and x is whatever my calculator says that number is right there. So I just need to carefully plug it in to my calculator. So clear log of 20 over 9, close the log, divide log in the bottom, 1.08. Close parentheses, enter. My calculator predicts it's a little over 10 years, which is what I guessed at earlier, remarkably. So let's see. Whoa, I just accidentally hit equals again. 10.3755-ish. I'm going to go to 3 decimal places, 10.375. I think the answer for x is about 10.375 years. Now, if they wanted the year here, that would be after 2010. So I would have to add 2010 to that, which should be in the year 2020-ish. The people will be, this is a weird sentence, about 160,000. Probably should have said population, huh? Am I right? I don't know. Let's check it. Well, based on my guess, I think I'm right, but I should probably plug into the original equation to check. So back to the calculator to check. Let's hold on to 4 decimal places for that. 3755. So 72,000 is the starting point. And we're growing by 8%. So there's 108% as the multiplier, raised to the power 10.3755. Now that was rounded up, so I expect a little over 160. Oh, pretty damn close. Nice. All right. Stay in touch. Do good math. Bye-bye.